Hi, everybody. Welcome to our session today, Tableau at Work for America. I want to give you a little bit of background on me and my colleague Kyle here before we get started. My name is Terry Caswell. I'm a senior associate with Hassett Willis. We're based in Washington, D.C. I have about 30 years of IT and management consulting, primarily in federal civilian agencies. Some DoD work, little private sector work there for a while. In the past 10 years, I've been focused in emergency medicine, public safety, and emergency management grant portfolio work. In my experience, the most important opinion in the workspace is the minion opinion. And what I mean by that is it's the people in the field, in your front door, in your warehouse, all the logistics people, the guys that had to suffer through the big enterprise solutions that never really worked and broke over time and were too expensive to replace. So they have the local desktop answers to everything about your business. And that's how I use Tableau, is to pull their answers up through the organizations to the decision makers. I'd like to introduce Kyle Pipkins. Kyle does amazing work in our FEMA and DHS workspaces. He is primarily responsible for our product delivery, a lot of which you will see today. He has an incredible ability to take disparate data sets of all sizes and shapes, cull the relevant data into sets that we can analyze and produce for our clients and for ourselves in some instances, often in a fraction of time compared to the types of analysis that government clients have been using for years. He assembles them into visualizations that get our clients eager to participate in the analysis and in the discussions and how do we improve a lot of the information that needs to go before the decision makers. And he's essentially creating a data-driven culture containing clear insights for better decision making. Slowly but surely, they're moving away from those flat file spreadsheets, the 12-inch reports, the notebooks that sit on bookshelves, and often in a fraction of time, and then they get really excited and they come back and like, Kyle, do it again. So in short, Kyle is helping our clients help themselves. They're learning that they have the power to do this themselves. You don't have to be, a 10-degree credentialed rocket scientist to drive some of the analysis that they need to do their work. So we are very excited to have you here today to allow us to show you how we use Tableau to help our clients help our country. So before we move into the meat, let me give you a little bit of background about us and where we play. When we talk about public sector, Hassett Willis, for about 8 years now, has conducted most of its work in federal agencies and workspaces that have the responsibility for preparedness and response. We have done it in FEMA, Homeland Security, primarily. We've also done it in Veterans Affairs, Department of Energy, Corps of Engineers, OPIC, and the FAA. We have extensive experience in helping government agencies solve complex challenges more clearly, that they harness resources that were previously hidden because they weren't even really aware that they were there. And we do this through a lot of strategic work in our data analysis and reporting, our organizational development, strategy and communications expertise, and also in program management. So without further delay, Kyle is going to frame for you how the application of Tableau really does help us help our clients, help our country.
Thanks. All right. So the takeaway of today's session is that innovation in government, like practical applications of Tableau, save lives, money, and human suffering. And we recognize that that's a very big statement to make. And so for the next 40 minutes, we're going to dive into it. And we're going to talk about 4 scenarios where we have used Tableau in the federal government in an innovative way. And we're going to explain how that has resulted in lives, money, and a reduction in human suffering. We're going to do that by talking about 4 practical applications. And you'll see that we're going to line those up along the data lifecycle so that no matter where you are in product delivery, there's a place for Tableau. A few disclaimers actually. We are federal consultants, contractors, so our talk here today is from the perspective of Hassett Willis. So we're going to be talking about a bunch of federal clients, but we're not representing them today. We'll make sure everyone's very clear on that. Secondly, because of where we play, a lot of the data has been scrubbed. So we've worked really hard to make sure that our products in our dashboards represent real data products that we've delivered. But when we start talking about averages and medians, those aren't the real numbers, which leads me into the third disclaimer, which is we are going to get a little geeky. We're going to jump out of our presentation. We're going to jump into Tableau, and we're going to show you and dive into some of the analyses and visualizations that we've produced and how they've been able to impact our products. All right, so let's set the stage. We're going to have 4 experiences for you. The first experience is FEMA Public Assistance Tornado Analysis. So back in May, a client from the Office of Public Affairs asked if we could, over a weekend, kind of do an analysis on the tornado that hit Oklahoma on May 20th of 2013. So the tornado caused $2 billion in damage, which is the third most in U.S. history, resulted in 24 fatalities and over 1,100 homes being completely destroyed. So that's the stage of this analysis. And it was a great exercise that we were able to go through because we were literally only given a map and pretty much asked, what can you do with this? And so that'll be the first example we walk through. The second example is FEMA-STAT, What's the Story? And FEMA-STAT is a group that works out of the Office of Program and Policy Analysis at FEMA. And they're really known for, and they have actually a really great reputation for, going out across the agency, collecting disparate data sets and telling people what they need to know out of the data. And so this particular example was talking about the rising costs and shrinking budgets, which if you watch the news at all, you hear about it, sequestration, budget cuts, all that stuff. But all of that was in the wake of finding a 200% increase in the number of disaster declarations that FEMA has to respond to. So the FEMA-STAT analysis will go through that and how Hassett Willis used Tableau to say, here's the story. The third example is unaccompanied children at the NRCC. NRCC is the National Response Coordination Center. That's also based out of FEMA. And unaccompanied children was a front page news event, very recent actually. It was back in May and June that it was kind of dominating the news for a little while. A couple metrics around it: 10,000 kids came across the border in May and June alone, and that's just the Texas border. And as a result, the White House asked for $3.7 billion in emergency funds in July. So there's a huge human suffering element there, because you're talking about kids that are coming from countries that are riddled with gang violence and drug cartels, and they're getting to the United States and they're being put in these facilities and auditoriums just filled with cots. And so anything we could do to help look at that process and reduce that time was really important. And then obviously with $3.7 billion on the line, if you could improve the process, you could cut that number down, right? So huge effort there. Fourth one is BioWatch. BioWatch is actually where I sit right now, mostly full-time, and it's a national surveillance network that monitors for biological attacks, so it's counter-terrorist focused. And speed to insight is extremely important here because you're literally trying to detect early so that you can treat early. And pretty much everybody knows with modern medicine, the earlier you can detect, the better your chances are of a full recovery. And when that translates into lives being saved, I mean, that's huge, right? So the faster we can get that insight out and the faster decision makers can use the data that we're collecting to say, yes, we do need to deploy this strategic national stockpile, that's really big. So they're all a little bit different. And they're different because FEMA Public Assistance is a kind of a one-time thing where speed is incredibly important, but there is an end in sight, right? Whereas FEMA-STAT's very administratively focused. So no matter what agency you're working in, everybody's kind of being told, we need to do more with less. And so there's an administrative side to that. Unaccompanied children is very different than those because it's got a very legislative pull to it. In the news back in May, immigration reform was huge. You don't hear about it much anymore, but what we expect is if those number of kids go up again, then it's probably going to come back into the news cycle and you'll start hearing about immigration reform again. So there's a big policy side there. And then BioWatch, we like to relate it to like transactional, like financial transactions or monitoring social media. Because it's a very persistent kind of a monitoring that's going on, where you're constantly on the lookout for something. All right, so moving ahead, this is our data lifecycle. We kept it really simple because everybody's kind of familiar with it. We just wanted to give you a frame of reference for our applications. So just to walk through it briefly, we're starting with collection, bringing in data, process that data, you move into analysis. We've separated analysis and visualization. We think that there's a lot of times people go to their clients with the analysis findings, and the story gets lost in the noise because you're telling them all these details that's not what they're looking for. So we like to focus on visualization as a separate effort where we take the findings of the analysis, but we package it in a way that it tells a very clear story that doesn't get lost. And that way it has a better chance of being integrated into the decision-making process. And then all of that kind of bottles up into decisions support, which is what we're here for, right? Growing BI and helping people make decisions. So the applications we're going to talk about are baselining, evolving business intelligence through analysis, clear insights using visualization, and reporting is decision support. And you can see how they all line up in different areas of the life cycle, so regardless of where you are, you can find a place for Tableau. All right, we're going to get started with baselining. So baselining is very iterative. It spans between collection and analysis, and what we mean by baselining is exploratory data analysis with a purpose. The purpose of baselining is to find out what's good with the data, what's bad with the data, what does it say and what does it not say, and where do I need to go focus my efforts so that I can answer the questions that are being asked. And that's what we went through with the tornado analysis. And so I'm going to jump out of presentation real fast, and we're going to show you the result of our tornado analysis. So this is a parametric cost model. And what it does is on the right-hand side, you can enter values for home value, homes destroyed, severely damaged, moderately damaged, population density, and then the distance and width that the tornado would have traveled through this area. And we came at this by doing a bunch of analyses, right, regression models and causation correlations, and we figured out that these are the important parameters for FEMA to be able to quickly assess the damage that was caused by a tornado. So this map down here on the bottom right is actually one of the maps. We were given two maps when we started this analysis, and this was one of them. This is a National Public Radio map, NPR. It was plotted with Google Crisis Earth, and I'm pretty sure it was up within hours, if not a day, of the actual crisis. So we were asked to take this and do something with it as it relates to public assistance. Public assistance is a grant that you can get from FEMA to help recover from a disaster. So whenever any type of disaster that hits, it might be a hurricane, tornado, severe flood, anything like that, FEMA goes out and they monitor and they pretty much just do a census of how much damage was caused. And if it meets a threshold for population density and things like that, then the survivors of that disaster are now eligible for funding. And so this map and maps like this are able to help speed up that process. So FEMA has a group that works on doing this. And so baselining, let me blow this up a little bit for you. So in baselining the data, what we do, and this will just be really quick, is we look for relevant past information. So we know we're working in Oklahoma. We're starting with a map that's telling us damage. That's all we have. And we know we need to go out and find information about public assistance. So we have a few different data sources here. We're just going to look at one real fast. And all we did was we needed to know what information we had that we can use to look forward. And so we counted the number of disaster declarations that we had, and we found how many were tornadoes. And so we had 18 disasters as a baseline to look at. And we also wanted to look at how many of those occurred in Oklahoma. And so you look at Oklahoma, and we have 2. And a couple things that dawn on me real fast when I'm looking at this is that, number one, the disasters were all spelled really well. Because you can spell hurricane or tornado 100 different ways if you really want to. And when you're looking at things as text strings, an extra space at the end really matters. And that's going back and changing processes. And so I'm seeing that I don't have Oklahoma spelled a bunch of different ways. I didn't have tornado spelled a bunch of different ways. And so I can trust that I have 2 disaster declarations from public assistance that I can use to help baseline my data and look forward. And that's part of the baselining process. So jumping into, that's a little weird, but jumping into what we actually did, we looked at national tornadoes versus Oklahoma, and we found differences. I'm not sure why this isn't populating right, but this is around 30%, and this was 83%. And so we figured out that there was a big difference in national numbers versus Oklahoma. And so when you put that all in a scatter plot based on the number of projects and dollars, we found a couple outliers in those 2 disasters that Oklahoma had in our baseline. And this one was for Grady County. And Grady County was one of the counties that was impacted in the May 20th tornado that we were looking at. So moving forward, we knew that we needed to figure out what this outlier was caused from. And so we pulled data in from the Census Bureau. We pulled data in from Trulia.com. We looked at the National Weather Service and got information about the damage that was caused. And we were able to basically figure out that the reason why the population density is low and the dollars that they received was high was because a neighborhood was hit. And that told us that the number of houses that are destroyed in a tornado is a huge indicator, at least in this geographic region, for the amount of money public assistance is going to allocate for the recovery effort. And that translated into debris cost removal, which is part of that 83%, and why that was such a high number compared to the national average. And so we looked at some other things, and I won't get too detailed here, but we figured out that there was correlations between cost per mile for an F5 tornado, homes being destroyed, and things like that. And that's how we got to this parametric model. So within, this was over a weekend, so we did all this in 2 days, and by the end of it, we kind of came back from the weekend, and they were looking at it and they're like, this could pretty much reduce the time to being able to give people funds to respond to a disaster by weeks. Because every day somebody's coming up from their bunker and their house is gone, their car's gone, they don't have any clothes, they don't have any food, and they're reliant on the Red Cross and FEMA and other agencies who are coming to respond to give them what they need. So the faster you can get them back up on their feet and get the debris off the streets, get their houses rebuilt, and help them recover from this disaster, you're really reducing human suffering. And there's also a huge cost administratively to FEMA being deployed in the field. So when FEMA deploys to the field, they're pulling people from across the country, and they're setting up a command center that's a hub for that recovery effort. And that's a really big administrative cost. And so any days that we can shave off of that so that they're recovered faster, that's also really huge. And when you can reduce administrative costs, that money can be reallocated to other efforts like building analytics. So that's our first example of how we baselined data in the front end to work through this life cycle and come up with, and this was a proof of concept, but to come up with a proof of concept for a parametric cost model that could help improve disaster response and recovery. So with that, I'm going to jump back into our presentation, and I'll introduce our second application, which is evolving business intelligence. And I really like this one because it's really, really vague, which means I can say anything I want, but we've scripted it. So what we're talking about with evolving business intelligence is helping to coach and guide our clients so that they understand this world of data. A lot of our clients don't work in data, right? They would come here and they would be totally overwhelmed by Cloudera and Hadoop, and this isn't their world. They're program managers, they're scientists, right? They're administrators, they're policymakers. And so that's everything they do needs data, but they don't necessarily understand everything that's being told to them. So when somebody comes and says, hey, I need you to do a trends analysis, or I need you to build a forecasting model, they're like, okay, I need to build a forecasting model, but they're just repeating what they've heard a lot of times. They don't actually know what all goes into a forecasting model. And so what we like to do with Tableau is we like to help walk them through the analysis and basically evolve business intelligence into being a more mature idea within these agencies. And so with that, I'm going to turn it over to Terry, who's going to talk about FEMA
Okay, so there's a directorate in FEMA called FEMA as Kyle mentioned earlier, and they have the responsibility of culling all kinds of operational and financial data and help answer some of the administrative issues at FEMA. So the problem statement is rising costs and shrinking budgets. In the 90s, there was an average of 59 disaster declarations per year. In the 2000s, there was an average of 153 disaster declarations per year. And we know in this decade that that number has also been increasing. So they wanted to try and figure out all of the costs associated with deploying FEMA personnel to a disaster. And I mean every component, every facet of costs. So we had 50 years of disaster declaration data, and it was a mess. It was tons of disparate data sets from years of enterprise solutions that was capturing all this information. And essentially the question is, how many people deployed on any given day? These are the days of active declarations, and these are the number of people. And it was ugly. So we set out to make sure that we understood all of the data elements necessary to answer this question. We had hundreds of data elements to look at, and part of the problem was that we had redundant entries across systems, we had nomenclature problems, we had field format problems, And we didn't even get into validating the data that had been captured. And that is a big problem area in the federal workspace, and maybe next year we'll talk about that at a session. But so we culled all this information down, and then we tried to find the commonalities. So we got rid of our outliers. Yes, this would be Sandy. So we took that out. And there's a phrase at FEMA, probably in the last year or so, they try and aggregate all the different disaster types into notice, no notice, and water. So those are the 3 highest gradient of disaster types. So we looked at that for a while, and we culled it down, and we culled it down. And we tried to capture it in commonalities by time of year that the disaster occurred, a geographic region, the disaster type, how long the duration of the declaration was, just trying to find all those commonalities. So the point was we needed to find the story, because the question was how much does it cost, but what they were really asking us without saying it was, had they been making the right decisions? All of a sudden, the language in these meetings kind of morphed into, we need a predictive modeling tool. And that got us all super excited, and everybody was coming around the table. So we had 2 weeks to look at all of this stuff. We did regressions, we plotted it 1,000 different ways, and you can ask my colleagues, the night before we were to pitch the result of this analysis to Mr. Fugate and some of the other administrators, I couldn't figure out what the story was. I was wigging out. I'm like, I don't know what the story is here. I cannot look at it any other way. And then the light bulb went off. That was the story. We could not discern any specific trend or story in their decision-making process. Not that it wasn't a good decision-making process, but ultimately what it turned into was these are long-time historical leaders in this agency who know their communities and know the regions that they support, and they know what they need because they know what they need, but we weren't capturing it digitally. And we literally were in this meeting, and one of the administrators, great guy, kind of leaned over and looked at me because I was really hoping that they were going to get this. And he says, you've got something you need to say. Yes, sir, I have something I need to say from the back row. I can't digitize your gut. Anecdotal information I cannot benchmark. So we had a couple of different things in this conversation. One was we need to improve data capture. And the other one was that they got a clear insight into their BI capabilities currently. Their BI evolved. They learned what they didn't know. We also had to gently point out to them, thankfully it was taken well, that this was all descriptive information. There was no qualitative analysis available because we could tell you how many people you sent when, but we could never tell you if it was the right number because we never did that analysis. We never captured that. We didn't take that feedback loop into a life cycle and say, here's where we are, here's where we need to be, this is where we went, this is what we did, was it right, and how do we course correct? We weren't doing that very well. So that was their clear insight into their BI through this particular story. One of the most nerve-wracking analysis I've ever been involved with. So, for the third practical application, Clear Insights, to me, this is the coolest part of Tableau. I've been using Tableau since 2008. My first version was 5.2. Got me out of a wicked jam. Everything was SQL. There was no reporting, and I worked with firefighters. Not a good combination. So I had to paint pictures. Firefighters work really, really well with pictures. And I've been doing it ever since. And I know that the value that I've experienced from Tableau in this industry has been the aha moments, where they realize that if the things are done on the front end, your data governance, your capture, your maintenance, your sustainability of that throughout years of technological progress, they too can sit down and do this. And one of the first things I always do with any data set I get, similar to what Kyle just did, what we saw him do this morning, is I say, oh, you got a great data set. Let's throw it in there. Let's see what Tableau says. And so you got this many rows, and you have these many fields, and these are your native dimensions and measures, and here's your field formats, and oh, you got a lot of nulls, you got a lot of blanks, where you wear that, and the light bulbs start going off. It also kind of helps us make sure that the client knows what they're giving us and kind of manage those expectations. But the better part of the clear insight for me is, like I was saying, when the light bulb goes off. So I have this client, I've had him for a couple of years, super great guy. He is an Excel power user and was totally resistant to Tableau. And he was an Excel user by nature, or by need, not by desire. He's a program analyst. He specializes in emergency preparedness grants. He knows what's needed in the field. But he has to report, and FEMA's got some problem with their legacy systems and grant management reporting, and what are you getting with that money, and what difference is it making, and all that's still a work in progress. But this guy is very passionate about his clients. He is a very highly credible government public steward. So, but I want him to use Tableau, because his Excel spreadsheets are color-coded for the top 10 and the top 5 and ranked for a greater than and less than, and it's helpful, but it's nowhere near complete. Now, this guy is also a huge NBA nerd. I mean, he knows everything about the NBA. The players, the teams, the stats, the profiles, the payrolls, the comparative from how they performed this year versus last year. I mean, he can dole it out. So one day, the Viz of the Day folks pushed an NBA Viz, and my light bulb went off. So I threw it on a tablet, got all geeky with them, ran down the hall. I'm like, dude, check this out. This is the NBA profile. This is Andy Kribel, I think his name is. He's a Zen master. So I threw it up there. And I'm like, look, this is, you know, the teams, the years, the players, the ratios, the better than, less than, all that kind of stuff. And I said, and you could see it. I didn't even have to say it. He's like, oh. And I'm like, yeah, these are your grants. These are your states. This is the money they've drawn down. This is what they're buying. This is the difference that it's making. And he's now one of our dashboard users. Absolutely he took the gospel and ran with it. So it was a good thing. Okay, I just went dead on my tablet here because I'm not reading my notes anymore. That's a good thing. Another clear insight is operational metrics. And now he not only knows what his grantees are doing, but he can start influencing his management, the people who are investing the money into the systems that the people need to get away from the 50,000 versions of desktop answers and get an enterprise answer. It's clear insight, it's speed to insight, and with that we're going to get into another very cool analysis that Kyle's going to share with us, and that is the unaccompanied children.
Right. So just to recap what unaccompanied children was, is that's the event in May and June, front page news, all the kids coming across the border. And Hassett Willis was asked to help our client at FEMA, who was helping the NRCC, the National Response Coordination Center. So they stood up the NRCC because there are different agencies, not all within DHS, that have to be a part of this process of when a kid comes across the border, they're apprehended, they're put into the care and custody of the United States. And so there are legislative policies in place that govern how long they can stay in one place and what those facilities have to have available to them and things like that. And so this is very policy driven, and when Hassett Willis got involved, our role was to take data, not just disparate data sets, but data from totally separate agencies, and to try to pull that together to tell the single path, right, the process of when a kid comes in and when they go out. And that was the goal of the analysis. And so as we were doing this analysis, questions kept coming up. And we found the analytical answers, but we needed to make sure that they didn't get lost in the visualizations. So what we're going to walk through is the analysis, the dashboards that we put together. So jump out of here, go into here. I'll reiterate one more time, these aren't the real data findings. All right, this one's really sensitive, obviously, because it's still going on. So these numbers are not accurate. They're representative of the actual visualizations, but that's it. All right. First question, where are they now? This was really important because as kids are coming in, they're being put into stations, right? And stations are getting overwhelmed with the number of kids that they have. And so CBP and HHS and all these other agencies need to know where else can we take these kids and where do we need to go? Where do we need to respond? Where should efforts be placed to help them move through the process? So all we did was a simple bar chart. We didn't go with a map because you actually lose some of the details in a map because we're looking at sector codes and we're not actually looking at a single city. And the other thing we were able to do is we were able to plot every individual kid and the number of days that they had been in that location. So if they wanted to focus on top to bottom, they could. And that was it. This is very simple, and it gave them exactly what they were looking for. The next one is not as simple. We went with well, the question was, I'll start with the question. The question was, how long do children under 12, under 12 was considered the tender age, and how long do they spend in custody? And so the first thing we did was we did a bar chart of how many we had in each age group for each age, because we need to tell them the context of it. So when you see that we have 2 records for a 0 to 1, I always found 0 funny, but 0 to 1, that's not going to do much. So you'd say, here's the median, here's the average, but it's 2 records, right? So we did that to put it in context. The other thing we did was we went with the box plot because, and you can see the dispersion. And that was really important to us because we didn't want to give them a single number and say, this is your 155 hours. And they lose the context of this dispersion right here and how big that dispersion is. So that was really important to us. So what we did was we used annotations. We just kind of highlighted this entire area to say these are going to be your outliers. We called out that these are 25% dispersions. We are using the Tufte rule of 1.5 or IPR, which is why there are some outside of the quartiles, geeky. And then we pointed to the median because that was still the big thing they wanted. They wanted to know what is the median. But the great thing about it was when we're telling the story, we can say, well, this is your median, but look at the dispersion. And the last chart I'll show you today dives into this dispersion and what might be causing it. The other thing that we really loved about this one is that we, again, told them the kids that were still in custody, but if you hover over one of these plots, this one's on the far right, you can see that blue dot, it puts that in context. So now they're not just taking the kids that are still in custody and saying, we got to get these kids out. No, look, they're barely above the median for all the dispersions. Is this really where you want to focus your efforts? So again, it's all about context and delivering that story. All right. The next one. This is the one, our client came up with this idea for this chart. And he had the idea before we had even pulled all the data together. He knew exactly what he wanted. And what he needed to do is he needed to show the amount of work that was going into each stage of the process. So when we're pulling data from CBP and HHS, they each have different processes. So we're looking at one kid and we're bringing all of these date fields in for every stage of the process that they work through. And that's what this says. When you start over here, you're coming into the process. And as you go down, when you get down here, now you're heading out of the process. And a lot of people are running around with the notion that if we apprehend 100 kids, we better have discharged 101 at a minimum, or we're not on the right path. And by looking at this and seeing kind of this diagonal way that this works, because we cut off the records for apprehension over here, you can see that there are a certain amount of days that you have to go through before you start being able to discharge. So when you have an outlier, like 384 on June 10th, you're not going to see 384 discharges on June 10th. That might take a week or 2 or a month. And that's what this helped show. The other thing it helps show is the amount of work that goes into this process. So we're not starting with any more than 268 or whatever the number is for this day. This is the number that we're starting with for new records. So if I have 137 on this day, but then I also have 142 in that next process, and then I have 190 in the next process, that's just more and more and more work. So it helps show that it's not as simple as taking one and getting them all the way through. It's different pieces of work for every kid in every stage. So that was this one. The next chart was where are they in the process? Again, simple question. Only focus on the top part. This is called the meatball chart. People really liked it. It kind of gained like a cult following at FEMA for a while, but it's a bubble chart that has one dot for every kid. And we did it that way intentionally because we wanted to show, number one, the volume, right, of the issue, how big of an issue this is. And we also wanted to represent every kid individually because that's really important, right? It's not always as simple as an aggregate. And so we assigned statuses based on the data for each kid, and we started them in the middle of the circle. So if you make it in the middle of the circle, you're brand new to the process, and the goal is to make it to the outside of the circle. That's when you get out of the process. And then we just gave them a bar chart to tell them again what it was. Client came up with another genius idea. He said, I wonder how many of these kids are actually 18. And that's because we had a lot of kids being brought into the process that were 17. So we did the math, and all we did was we plotted all of the dots that were 18 or going to turn 18 before they would realistically make it out of that process. And we showed it on the same chart side by side so that you could say, these are your kids. And then if you look at all these black dots in this bubble chart, these are all the ones that are going to age out or are aged out but are still in the process. And that gets into the policy piece of this, right? Is that a micro-strategy that could help change legislation so that they could address this issue better? And so that a cot for a 5-year-old is free because there's an 18-year-old that's no longer there. So those are the types of things that this kind of analysis can do. The last one is what matters most. We were talking about the box plot and the dispersions, and why is there a range of 200 hours that 50% of your records are fitting within. And this it still is. It's a little complicated because we have a lot going on, but we basically wanted to plot all the key attributes that were a result that we could find that were going to result in time in custody. So we looked at age, we looked at gender, and then we ran some regular expression queries to find health fields like pregnancy and sponsorship. And we annotated it because we didn't want anybody to have to do the legwork of figuring out what we were trying to say with this. And so all you really have to do is kind of read the annotation and say pregnancy matters, right? So for females that are pregnant, they're going to spend more time in custody than females that are the same age but are not pregnant. And this type of sponsor you have, that might matter, right? Because this is what this is showing. And so everything's plotted up against the median, the quartiles, and things like that, and then the annotations give them their clear insights without having to do much interpretation. And that is the UAC analysis. So I'm going to jump back over to here, and I'm going to let Terry introduce reporting.
So reporting is probably the most common exciting point, especially from our new clients and users. They see that the visualizations really help drive some of those conversations and the discussions. And they want to remove the bottlenecks. Like we said earlier, there's tons of flat file spreadsheets, there's manuals and reports and process documents that just, that's why we had a Paper Reduction Act, and yet we still use them. And so we had a particular client in FEMA who is responsible for reporting out the financial transactions of the grants. And these grants have been in play for the better part of 12 years now. And they are old legacy systems that we would love never to have to use again, but here we are. So we had the challenge of culling data to generate a biweekly and a standing monthly report cycle, as well as countless, endless numbers of ad hoc queries from Office of Management Budget, Capitol Hill, the White House, everybody. And so ultimately what we did is we took Tableau as our centerpiece, and then we reached out to all these disparate data sets. We figured out what data was necessary. We culled it down into 2, and that was more of a governance issue than anything else. We reduced the assembly time for these reports by 40%, and that's a lot of money in government time. It's also a lot of contract dollars, but that's another conversation. It's difficult being good sometimes. But the other thing that it did is it got these people around a table to realize that they could drive the conversations that result in the queries, that you go out and you do those ad hocs, or you say, this report is not giving me anything meaningful. I want to do it a different way. And what we wanted to do with the rapid visualization component is get them around a table so we could do the live what-ifs. So if you change this parameter in this period of time and you compare this state to that state, what are you actually trying to get to? It is not, it's not a habit yet. We spend an enormous amount of time capturing images in Tableau and pasting them into PowerPoint. And I suspect we'll be doing that for quite some time. But we got people carrying tablets around, and we got people carrying laptops around, and we got people pushing keys to see how it looks different if we change the conversation a little bit. And that's where the clear insights feeds into that data lifecycle and gets into the reporting, removes the bottlenecks, gets to the single source of the truth. There is a little bit of a learning curve with a lot of the clients when they understand if I push the button today on a financial transaction system, the image I get may be different than when I push the button tomorrow. But it certainly invites debate, and that's what we need. That's how we're going to change things, is getting them around the table to talk about doing things differently. And now Kyle's going to share one other practical application of reporting, and that is our BioWatch program.
Yeah. So BioWatch, you can read about it. There's only so much I can say about it, though. And it's biological attacks is what it's monitoring for. And so when I was talking earlier about it, speed to insight is super critical. And we have operations that are constantly going on where our sensors are out in the field and they're looking for these agents. And what we need to be able to do is not just collect and process that information effectively, but we need to be able to actually give it to the people that have to make decisions. Like I was saying about the strategic national stockpile, that's a huge decision to make. I mean, the cost is enormous for pulling the trigger on that one. So if you can't give people the right data, they're going to not make that decision. And if it is a real event, there's huge implications there. So Tableau server solves that for us. We're not going to show any BioWatch data or fake dashboards, but we are going to go into the Hassett Willis Tableau Online infrastructure and just kind of share with you the process, and with BioWatch being in the back of your minds. So let me go over to here. All right. So if we're thinking about BioWatch, there's field operations, there's laboratory operations. They have performers we have a huge business team, right, that monitors all these contracts for performers like the national labs. And everyone has different pieces of information that they need to know to make this program effective. And all of that information needs to be stored where anybody can get to it, because if I'm working on field operations, there is really pertinent information to me that resides at the business office. And being able to get that across all of the work streams or the stovepipes is really important. So if every project represents one of those stovepipes, then you can dive into any one of them. So we have TC14. So you dive in here, and these are some of our public visits that we have. But if you're thinking about it, and I'll jump into this one, this is disaster declarations. But if you can imagine that this had something to do with BioWatch, being able to come in here with a URL and give this to somebody really quickly so that they can say, you know what, I want to look at hurricanes. So all they have to do is click on hurricanes, and then they can see the pattern in hurricanes, and that along the coastline there's obviously going to be more hurricanes. That's not real insightful.
But what was insightful, sidebar real quick, how do you get hurricanes up here? Those were Katrina evacuees. So when the federal funding went to those counties to help those counties invite and help those people, there were disaster declarations declared associated with money. Mm-hmm. And that's how you get hurricane declarations in the upper Northwest.
Yeah. So if this was BioWatch, and you said, and this wasn't disaster declarations, but this was monitoring for some type of noise, right? Or we're trying to find, like, you want a static line in BioWatch. When you see a tremor, that's bad. So if this is what we're monitoring, and we can say, here's a URL, log in, go and check it out, and then come around the table and have a conversation about the same piece of information. Because the old process would be, all right, probably me, hey, can you write a query, go get this data, send out an email with an Excel spreadsheet or something in an email, and now you've got different versions of it because you have to turn around and do that the next hour. And so you want everybody to just go to a URL that's pulling the most recent version of the data, and you don't have to deal with configuration management changes. And that's what, and this is Tableau Online, but that's what Tableau Server does at BioWatch, so that you can really have that speed to insight and decisions can be made. And these are big decisions. All right, let me jump back over to the presentation, and I'll let Terry wrap it up.
So as you've listened to our examples today, we hope you have picked up on our theme, which is time does equal lives and money, especially when we're helping our clients respond to disasters, whether they be natural or man-made. What do we need? Where do we need it? How do we need it? Why do we need it? Will it mitigate economic costs? Will it reduce human suffering? Tableau helps us dissect these patterns and trends from past practices and influence decision makers at the government level to improve their data capture so that they can assemble it more quickly, analyze it, clearer insights, better decision making. We also think it's less assembly and more analysis. A lot of these types of clients, they don't believe if it didn't take a week to get to them, they're not going to trust it. They're not used to that. They want that delay because there's a trust factor there. And we're trying to impress upon them that we don't have the luxury of that anymore. We have so much data that we haven't really quite figured out what it says, that we need to get busy with it. We need to get geeky on it. That's what we say. So Tableau has helped us help our clients make informed decisions more quickly, translating into saving money and saving lives. And we hope that you have gained some insights in how we do this for our country.
Thank you. So we have a little bit of time. So I'll send out a gentle reminder that you can go on the app, and if you liked our session, you can rate it. And if you didn't like our session, you can forget that I said that. And if you want, we can take questions, or we can go back into Tableau online and show some other business. Yes?
So earlier you mentioned HHS and Border Patrol is also providing information. So do you all collaborate with them? Is there a way, like a kind of a life cycle collaboration with them?
Yeah, so the question was, for the UAC analysis, we were working with CBP, Customs and Border Patrol, and HHS, the Office of Health Affairs, or was it HHS?
HHS, Office of Health Affairs,
Yeah.
OHA.
No, it's OHA,
Yeah.
right. So for that project, we collaborated with them because it was at the NRCC. So the NRCC doesn't really matter what agency you're with. When the NRC gets stood up to respond to an event, everybody gets pulled to the table. So it's a huge command. I mean, you can, I think you dig door, but it's basically a big command room. And it's open floor concept, and they basically pull in teams from all different agencies. And that's how FEMA got involved, because this wasn't a native FEMA issue. FEMA really didn't have a role in it at all. But everybody knew that NRCC has responded to events that are similar in nature to this influx of kids. And they knew about our clients group, who's really got quite the reputation for being able to wrangle data and make insights out of it. So that's what happened. They said, well, let's get FEMA on it, and let's get this group on it. And that's why we were able to coordinate with CBP and HHS. Now, out of that process, we did most of our scripting and analysis with Tableau and VBA and SQL. But out of that process, they're moving into basically building an enterprise version of a database that integrates the agencies, so that in the future, when this issue continues, they won't have to run through this again. They'll have it ready to go. Yeah. Any other questions? Yes.
Do you get asked to synthesize your dashboards with, let's say, legacy ESRI platforms?
Yeah. So, do you want to take that one?
Go ahead. You go first.
All right. So, do we get asked to synthesize our dashboards with legacy ESRI platforms? We have to. It's a fight. So, we have gotten Tableau integrated into the federal space through a very grassroots process, and we're very lucky because we have clients that get it and are all about creative process thinking and problem solving, and they understand that there's an art form to these things, and that you do lose the ability to make decisions on data when you throw out analyses that don't tell a story. So most of our efforts are separate from ESRI, but where they get combined is that when you have a legacy system that's in place and you say, like, we want to stand up Tableau server, well, there is a data warehouse, right? And it currently exists, and it's been scoped, and it's there, and we should be using it because it's there. And so sometimes it's really hard to start a new project where you want to stand up Tableau server, because you do have to find some type of collaboration with the existing systems. We haven't had to take any of our dashboards and rebuild them in another way. I was recently working with some folks over at DHS S&T who saw that as an application of Tableau, as like rapid prototyping of things that then they would go and build in business objects or stuff like that. But yeah, it's more of a where do you find the path where you can kind of work together.
The other piece to that would be to not throw the baby out with the bathwater. So a lot of larger agencies have invested heavily in an ESRI license, enterprise license. FEMA now has a chief geography officer, and they're doing really cool stuff. But it's complicated. It's not in a language that the minions understand necessarily, and it takes time to compile, to vet, to get approved, to get it in front of people. We can do it quicker here, and then accompany the other types of information that Tableau can compile next to those ESRI products as an agency report. It's bureaucratic. There's no denying it. But they do complement each other well, and we, truthfully, would love to have a client that has a little bit more map servers. So the answer would be yes.
So I was initially pulled over for 1 week that turned into 2, that turned into a month. But the visualizations took about 4 hours. The lifespan of the project to get to that point was 2 weeks. So we had 2 weeks to pull everything together, and we were expecting to be able to do it within 1 week, but then we realized through baselining our data that we don't have anywhere near what we thought we did, and that we had to go back out and collect more stuff. And so that was the process. So once we had a data set that we could actually use to answer the questions, it didn't take any more than 4 hours to pull that analysis together. Yeah, so again, I can't speak on behalf of them, but we had several meetings with them where we basically said, this is what we did with it. Here's the data set, right? Is this helpful for you? And would you like us to show you this process? And that's part of why there's an effort right now to build that as an enterprise database that can be used across the agencies. It's because they did view it as being useful, and everybody kind of saw where pulling these disparate agencies together was going to be really helpful.
We helped our client build intellectual capital, our client being FEMA, to the point where we were thankful for this challenge, but some of the other agencies, CBP initially, they wanted FEMA to own this from here on out. Well, that's not FEMA's mission.
Right.
But what we were able to do was package it for FEMA to sit at the table with these other agencies and say, look what we as a team have done. We hand this to you. We'll be part of sharing our feedback loop so we do it smarter, better, faster the next time. And FEMA will gain some leverage out of that. So, yes, sir.
Yeah, when you were talking about the BioWatch project, I have to imagine that some of the data is in unstructured form. Can you talk about some of the work that had to be done in the baselining phase to get it to something?
Yeah, so that's been the last 10 months of my life. And we started with a bunch of questions that we couldn't answer. And I have to be a little bit vague, but it's very similar with other projects that we've been on, where the questions are coming at us and the information was being collected in Word documents. And like Terry said, it's really hard to quantify qualitative information from a get-go. It's even harder to do it when it's strictly anecdotal. And so we went through probably 3-month process of sitting down with stakeholders across the entire program and figuring out what these buckets of information needed to be based on the questions we were being asked, but also based on the work that went on in the field. So there was a steep learning curve there where, as being the IT guy, in the back room doing data stuff, I went out with the field operators and pretty much became an expert on everything field and lab, and that's how we handled it, right? So becoming experts on dominions, right? It's dominion opinion. You have to become an expert on everything to be able to really address it. So 3 months of that, we rolled everything out in about 2 months. We built the new collection processes, and we rolled that out in 2 months, and then that's what we were left with. So the innovation there, not the Tableau piece, but the innovation that's not Tableau, is that we are leveraging existing infrastructure. So they're building new pieces to collect information without having to really have a human do it. It's barcodes, transactional type stuff. Very digital, great advancements. Using existing infrastructure, we were able to write SOAP requests with PHP to pull stuff off of SharePoint and into a database that can then serve as our live feed to our dashboards. And that's how we were able to use the existing infrastructure of SharePoint to actually collect a lot of the information, which isn't really one of its native uses, but it worked really well for us because everybody knew how to use it. It was existing. Yeah. That help answer it? Yeah.
So kind of a two-part question. Just so you know, when I asked this question, I was Deputy Chief of Operations in North Carolina for emergency management, so I know from.
Yep. Thank you.
So here's my question. You played two things there that were really important to me as a state person. You had the debris problem, right, that you did with the tornado, which when you take a hurricane is magnified by hundreds, right?
Mm-hmm.
And you also add in the vegetative side as well as other things, right? So you have the C&D and the vegetative. Then you also had your personnel costs early in that disaster. Those personnel costs are spiked so early in that disaster because they're debris monitors, right, and they're out doing damage assessments early. So those two things cost a lot of money.
Mm-hmm.
What's the next iteration of putting those together, looking at predictive models for that, and then monetizing that or marketing that to states, especially up and down the East Coast, who have this problem on a frequent basis? And I do sell to those state and local governments for band in the Southeast, just so you know.
That's good. I have a card up here, and we can talk outside.
Yeah, let me go ahead and get that one out.
Yeah. I will say philosophically, let me answer your question that way. It is an iterative approach. I have played in state and local, and 2 years as a Fed at FEMA in prep grants and fire grants. And Terry's opinion, not Hassett Willis's and not our clients, but the federal picture will not improve until this iterative process includes data capture, analysis, and clear insights from the locals and the states. The feds can't answer it. These two can't answer it on this side. And that's part of our company's philosophy, is that type of relationship, so that we're sharing the lessons learned at the highest level with the most data, not necessarily the best, but sharing those insights and taking them down to the locals and states and incorporating the resiliency models. And that's something for another time, too.
Yeah,
But
their debris plan is a predictive side to say this is what it should cost. We begin to identify fraud,
Yep,
contracting
absolutely.
issues, et cetera. So
Yeah,
they have a huge opportunity.
time equals lives and money.
we didn't go into this much detail, but we worked with, I didn't know this was an actual career field, but a debris economist. And I've learned that one. I figured out really quickly that I was way out of my swim lane. But we worked with a debris economist on the debris calculations for the tornado, so that they would be actually good enough to be a proof of concept. And I can't speak for FEMA, obviously, but I'm going back. We get back on Friday. I actually have a meeting on Monday to talk about that, and that was done in May. And so it's not been lost. There are groups that are working on it. There are iterations in process. There are statistical teams throughout all the agencies we work with that get it. And so I don't know exactly the next stage because I'm not a FEMA employee, but.
If you think of $2 billion plus of debris, with a plus or minus ranking of 30% for estimates from the U.S. Army Corps of Engineers, that's a $600 million window of potential fraud.
Yeah.
A lot of money.
Yeah. Yeah.
Yes, sir? Did you have I thought you raised your.
Yeah, I had a question on the company children. So you get two databases, one children coming in and one children going out, and merge those databases together.
Yeah, well, we had Excel files that were being delivered on a daily basis, and then we also had databases that we were trying to connect to. And so we wrote JavaScript and SQL and VBA code to either open Excel in the back end and do all the parsing with JavaScript by basically just adding something to a folder, or we wrote the VBA and SQL where you could launch a macro and scrub it. And so what we would do is when we would get the data, we would create basically a daily snapshot, and we would take that daily snapshot and we aggregated it over the time that we were in that process so that we could tell from when we got in, and we worked backwards too. So from when we started our analyses moving forward, a day-to-day look at it, and then everything aggregated up as well.
How about the individual attributes of the database? Were they standardized?
Yeah, so each agency was very different, but we got, in some cases, I won't say who, in some cases we got really good data documentation, and in some cases, this was a real fast increase that people weren't expecting. So in some cases, the Excel files weren't accompanied with anything. It was just color-coded. We called one of them the Technicolor Dream Sheet. And so in some cases, they were color-coded, and they weren't structured the way that they should have been structured. And it was just one of those things where you naturally move forward. But there were efforts that were going on in parallel. So we were just one of several efforts to help this. So our effort was to look at the data, bring it together, and see what the process was for a child. There were other efforts that were looking at the data files as they existed and figuring out how to normalize them, build schemas, and create databases to fix that specific problem. The database that we built was looking at the sheets together. So, if one agency replaced their Excel file with a database, all we would do is replace our data source. We would still be merging it. Yeah.
Four great use cases. Which use cases got you the greatest visibility of?
I don't know.
Well, it's a great question, and I would love to have one answer, but when you think about it, I'm glad we have four, because each one of these, like Kyle said earlier, they apply to different parts of the life cycle, but they also, one is tornado. You can't forecast a tornado. We're not going to build that specific analysis in advance. We have to have generic pieces in place, and we have to be out there, and we have to have it in their hands. And they had that, I don't know, I want to say within 6 hours they were forecasting. Within reason, hopefully not quite as broad as what you mentioned. Then you've got the UAC. That's a policy driver. That is, the policy says this person goes from this shop to this shop to this shop to this shop without any, wrapping about expectation on time, no performance metrics. I mean, they hadn't even been monitoring it until it became a big problem. FEMA stat in my part of our world is administrative, and I get more involved with clients about how well are we performing. I'm looking more at performance metrics. I love metrics. And then reporting. Reporting's all over the map. It depends on who the audience is. We've got internal players. We've got, FEMA is paired with X number of other agencies under DHS. You have OMB, you have Congress, you have Senate, you have House, you have all those committees. So reporting always takes a little bit of a different flair, so you've got to be scalable in that regard. The piece that's not up here, that I can't wait to get into more soon, is the knowledge management piece. So we create all these great reports, and we create all these vizzes. And what difference did it make is not only about how did we provide them information to make decisions, but how did we ourselves as consultants influence decisions by driving this viz. Did this viz result in the decision we needed? Did this viz, did this data design, did this baselining approach, because there's 1,000 different ways to do that. So the next vision that I'm trying to further in our world is that we document how we do it. Last year in DC, there was a lot of discussion about how you manage we call them the TWIBICs. How do you manage your workbooks, right? But there's another KM piece to that I'm looking forward to playing in the future, and that is, did it result? Was the performance metric met based on that visualization with that client who had that need at that time?
Yeah. Now, the only thing I would add to that is, to try to give you a straight answer would be that for the grassroots build, the tornado one had the most visibility because it was more of the minions that were looking at that and saying this will really help us and this is going to drastically improve our ability to respond. For going to Congress, the UAC, it was already at a really high level. Our client, presented it to the NIMIC and the upper levels of FEMA, and it just went straight up really fast. So that one probably had the highest visibility in that way. But as far as value, I think the tornado has been the one that FEMA has probably looked at and said, yeah, let's keep looking at this. Mm-hmm. Which Sean knows because he's a part of those conversations. Any other questions?
Thank you all very much for coming.